Okay, let's try this one here. 3 over 2x equals 4 over 3x minus 1/2, or minus 1/2. You can put it on pause and you can give this one a try, and then unpause it, and we'll see how you did. Okay, our non-permissible. Well, can we factor the numerator and denominator any further? No, not in this one. Identify our lowest common, our non-permissible. X can't equal 0. Our lowest common denominator between 2, 3, 2 is 6, and a single x. So we're going to multiply 6x into the numerator of each term. I can make it stand out this way. 6x. What's 6x times 3? That's 18x over 2x. Equals, that's an equal sign. 6x times 4, that's 24x over 3x. Minus, and 6x times 1, that's 6x over 2. These can be simplified. 18x over 2x, that reduces to 9. 24x over 3x, that reduces to 8. Subtraction sign. And 6x over 2, that reduces to 3x. Now we solve the resulting equation. If I bring the 8 to the other side, 9 minus 8, that's 1 equals negative 3x. Divide both sides by negative 3. Cancel each other out. X works out to negative 1 over 3. Is it one of our non-permissible values? No. And we could check it will satisfy the original equation. Okay, this one's a little trickier because we got binomials in the denominator, but still the same process. Our non-permissible values. What would I have to put in x? Make this bracket equal 0. 5 or 1. So our non-permissible is 5 or 1. Make that stand out some more over here. This says x plus 2 over x minus 5 equals x over x minus 1. Find the lowest common denominator. Well, the lowest common denominator occurs by multiplying the two denominators, x minus 5 times x minus 1. Leave it in its factor form. It's going to be more helpful for us here. We're going to take that LCD and we're going to multiply it into the numerator. It's going to get large here before it gets smaller. So I still have the x plus 2 or x minus 5. I still have the x over x minus 1, but I'm going to take this numerator, this LCD, I'm going to multiply it into the numerator. X minus 5 times x minus 1. X minus 5 times x minus 1 into the numerator. Now we'll see if there's any common factors, top and bottom, that we can cancel out. Yeah, we got an x minus 5 in the top here and in the bottom. All that leaves us with is x minus 1 times x plus 2 in the top. And then the other one, we have an x minus 1 in the top and an x minus 1 in the bottom. And all that leaves us with is x times x minus 5. We got a new equation. No fractions in there. Solve the resulting equations. We'll have to expand and collect our like terms here. X times x, that's x squared. When we expand this, collect our like terms, we're going to end up with x squared plus x minus 2 equals x squared minus 5x. Solve this equation. The x squareds cancel each other out. We end up with 6x. If we bring everything from the right side to the left side, we end up with 6x minus 2 equals 0 and solve the resulting equation. Let's see here. 6x equals 2. X equals 2 over 6, which reduces to 1/3. Is it a non-permissible value? Nope. That's our solution to the equation. Okay, here's another example here. It's getting a little more challenging here. We got binomials and denominator. Remember, first step, we want to factor all our numerators and denominators. Numerator, no, that can't be factored, but hey, x squared minus 9, that's a difference of squares. I can factor that. factors up to x plus 3 and x minus 3. Brackets around there. Good. Now, what is our non-permissibles? They're positive and negative 3. Can't put negative 3 at x here or positive 3 at x here. And our lowest common denominator. We have an x minus 3 and an x minus 3 in each one, so we have x minus 3. And in the other one, we have an extra x plus 3. So there's our lowest common denominator. We're going to multiply the LCD into the numerator of each term. I've separated it out by a long line to make this stand up, and I've already set it up. We'll put the LCD in the numerator, x minus 3, x plus 3 in here, and x minus 3 and x plus 3. Okay, there's our lowest common denominator. Is there anything common top and bottom we can cancel out right now? Yeah, we can take an x minus 3 out of the top and the bottom here, and the x plus 3 in the top and the bottom. And all that leaves us with is the 7x minus 15 equals. And what's common in top bottom here? Ah, an x minus 3 in the top and in the bottom here. We have x plus 3 and x minus 2. No more fractions to work with. But it looks like we're going to end up with a quadratic equation here. I'm going to bring this over here. 7x minus 15 equals, if we do FOIL here and expand and collector-like terms, we've got x squared plus x minus 6. Let's bring everything to one side of the equation. 0 equals x squared minus 6x, looks like, plus 9. We got ourselves a quadratic equation. How do you solve quadratic equations? Factoring, or use the quadratic formula. You'll have to look that up. This one, fortunately, can be factored. 0 equals x minus 3 times x minus 3. What would I have to put in x to make this bracket equal 0? Equal 3. Or how about this one? It's the same. X is equal to 3. That was the solution that we came up with. But wait a second. Is it one of our non-permissible values? Oh, the potential answer that we got was 3, but it's our non-permissible value. That is the answer to this quadratic equation. But it didn't satisfy the original equation. So we would have to reject our answers and say, no real solution. There is no real number that will satisfy. We're going to put it into x here, 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 and here. We'll make the left side balance the right side. Okay. The process that we went through was correct, but we found that the equation has no solution.